Welcome back. This is Asphyxium, and welcome to the How to Make a Master System Game Using Devkit SMS tutorial series number 14. In this tutorial, we go over the bonus entity logic, describing its behaviors during its three main states. We also go over the logic that updates the positioning of the bonus. Let's dig in. Okay, let's start putting our source code for the bonus entity. I'm going to start off with making our constants again, much like we did with the player source code and how we did with the ghost source code. Now we're going to do it here with the entity source code. And while I'm doing this, making the constants within the source file, this isn't the only way you can do it. You can put it as part of the source code, which that's essentially what I'm doing here when I put these constants within their source file, or you can create that binary data instead, or you can have this external data that can be binary, or it can be this within the source code. So you can have it in a bank outside of the actual source code. It depends on whatever your needs are. But for this, since again the source code is pretty small, as in it can fit in that bank 0 and bank 1, I just put it as part of the source code here. And then for all the other resources, when it comes to audio and when it comes to the graphics, I put it within our assets folder as a bank, or something that can be bankable outside of the source code banks. So just want to explain that this isn't the only way you can put data within your project and access it. If you need the room when you're doing source code, you may want to move some of this information outside of bank 0 and 1. So here we have some constants, again, unsigned car, and we're going to create our meta sprites as we were continuing on where the ghost graphics left off. So here again, we'll go and look at this. So this was the last bit of graphics that had to do with the ghost entity. Now these upcoming tiles, these are going to be loaded in at the beginning of a stage, and I'm going to be loaded in depending on whatever the stage level is. So on the first stage, the cherry is the first graphic, so we're going to load in the actual sprite or meta sprite graphics we're going to use. Then we're going to load in whatever the score value is for this bonus, which is 100 points for the cherry. Then we're going to load in our markers. So the first one will be the down marker, and then the last one will be the up marker. And in the first stage, the cherry shows up on both bonus entries. So as I said before, the bonus comes into the screen twice. Once when the player has reached 70 pellets that it consumed, and again later when the sprite count is at 170. So during those two times. Now for these graphics, if I couldn't just load them into VRAM altogether and keep them there like we do with the ghosts. So what we're going to do is that other sheet that we created during the resource portion of this tutorial, we have a sheet here that we're going to read from when the stage starts up. So it's going to see what stage we're currently at. It's going to load the appropriate graphics into video RAM or VRAM, but we're only going to load in what's necessary. So it's going to be 4 meta sprites for the first bonus, and then 4 meta sprites for the second bonus. And this is just free area. And the reason why I have two sets here is because later, when the bonus items start getting randomized, it will randomize from the first time it comes in, and it will randomize on the second time it comes in. So if it was just that the same bonus would show up for the first and second time, we would only need these first 4 meta sprites. But since it comes in later, and I don't want to stream tiles in during the game, because it would be a little too intensive. Again, I played with this a little bit, streaming them in before they get presented creates issues within the actual processing. Mainly, it doesn't affect anything in first play when you're using player 1 or in player 2 mode, but it does have significant overhead when you're doing it within team mode. So this is the way I did it. So we would get those 2 bonus items when the stage starts up. During the other processes, when we load the graphics for the actual level, and then we load all the other graphics like the ghosts here. So they will all be loaded in the beginning of the stage, and they're only loaded once. So I'll show you that when we get into the stage source code. So that's my long-winded explanation. So we're going to define the meta sprites going forward from where we left off with the ghosts. So here you see we have tile ID 220, and then 222, 224, 26. And here the meta sprite, the first one, is the actual bonus, so that will actually be showing up on the screen. And then this would be the meta sprite that shows the points after the bonus has been consumed by the player. And then this one is the bonus down marker and the bonus up marker. So those are all the meta sprites. And you can see the last tile ID is 234. And again, to reiterate, when it comes to sprites, if we pick the first half of RAM as our place to put our sprite graphics, and we can tell Devkit SMS which one we want to use, if we want to use the first half of the VRAM or the second half. Second half, you won't get as many sprites in it. You only have 192 tiles technically to play with there, whereas the first half is, of the VRAM, you can get 256. So we need all of the 256 from the first half of VRAM, so that's why we're using it. And then the second half of VRAM is where we're going to put our background tiles for the stage, and you'll see that as we get again to the source code for the stage. So here's where we define all that for the first bonus that's going to come in. No different than we did with the ghost. And this is what we're going to do for the second bonus that comes in. Here we continue 236, 238, 240, 242, 244, 246, 240, and then 250, and we're getting right at the end of the maximum amount of tiles we can have. So there's our definitions for each one of those meta sprites, and again, to go over that again, the meta sprites would be these two. It would be one tall sprite and the second tall sprite, and then these two combined as one meta sprite. So we have 1, 2, 3, 4, and then the second one's 1, 2, 3, 4. So here we're just making a pointer array to each one of these. So this is the sprites, and we're just going to have a pointer array for, because again, there's going to be 2 bonuses, and then the points, and then the markers. Nothing too different than we already done. Here you have some constants where we will define a tile index and where the bonus will show up. So these are randomized, and there's only 4 entries total. As you can see, some of them are repeated for the stages that only have 2 entrances. And we have 7 of them because, as you remember in the beginning when we were building these resources, there's only 7 unique stages. There's total of like 25 stages, but only 7 of them have unique layouts. So that's what we're doing here. So for each one of those layouts, we're going to define where the bonus can enter. So if we take a look at that real quick, so let's go to stage 1. And maybe, so this is stage 1, and what is going to happen is we'll have any range from 670, 642, 354, and 382. So when we look at that in indexes, the 354 is where it's going to start. So 354 is where the bonus entity will start, which is technically this little dot here that will start in when it comes in. And one of the other ones is 642. So again, 642, it's going to be right around here where it's going to start. And if you look at the other one, 670, it's going to be here. So these little corners here are 382 is where the bonuses can spawn on this stage. And we just do that for all the other stages. I'm going to go into each one of them, but it's generally the idea behind it. This array is the directions that the bonus will have access to guide it along. It's instead of the bonuses being randomized and going different places, then exiting, it is actually in the original game a hard-coded value. So the general behavior will be it will be that the bonus will enter whatever spawning point that's been randomly selected. And then, so if it comes through here, it might have the pattern might go like it goes this way and then goes down and over and whatever. But the idea is that at some point it's going to get to this one tile here. No matter where it comes from, it'll end up here at some point. And then what happens is there's a hard-coded array of where, or coordinates of where it's going to go once it hits here. Once it hits here, it makes one round around the ghost house, and then when it ends up back where it started, then it'll pick another random path to exit. So it has a random path, 4 of them that can select to enter. Then it has a base path of going around the ghost house, and then once that's done, it has another random pattern of where the bonus will leave, and it's all hard-coded. None of it is randomized. So that's what we're going to do here. So as you see, it's just an array of numbers, so nothing too fancy here. And what do these numbers mean? They are the direction constants that we've been using up to this point. So these defines here that we made for the direction right, direction down, direction left, direction up, these numbers are what is represented in this array. And here I don't bother using the define name, the readable name. Instead I just use the values, just so it's not crazy if I put them all together. It would be more readable, but here we're just going to hard code it to the values that they are. So here it would say that if we have 2 is to the left, so we move to the left 1, 2, 3, 4, 5, 6 tiles, and that's what that means there. So once we hit this part here, we're going to move to the left 6 tiles, and then we're going to start going up. So we can take a look at that. 3 is going up back here, so up is 3. So we do that 1, 2, 3, 4, 5, 6, about 6 tiles again. And then we would go to the right, which is 0. So we go right X amount of times, and then we go down X amount of times, and then we go to the left 2 more times to get back to that source tile, and that will end the path that the bonus will go into for the circling around path. So that one's always used no matter what random path is being used for entering the stage or exiting the stage. So we're going to do a lot of constants here. So here is stage 1's enter path. So all this is the same kind of thing that this is, but it's based off of whatever random path that they pick. So there's 4 paths that you can use entering the stage, and we define them here. I'm not going to go over all these. There's more information out there if you want to see what the exact paths are, but essentially all it is a bunch of directions that the bonus can go. Now, from what I understand, the original code isn't like this. They would have, I think it had like, I might have had 2 bytes, or maybe it was just a byte with 2 nibbles in it or whatever. But the first number would be how many times the second number would happen. So it would be a combination of pairing. So it would be that first number is the number of times that the second number, which would be the direction, would be going in. And I think that's more optimized, and I could have done it that way, but I felt like this was just easier to put together. So, and that's why I did it that way. But there's other ways of doing things. There's more than one way of doing something. This is more, I would say this is less optimal versus what the original was, but to me it's a little more readable if I present it. And I don't have to do any other sort of more complicated reading of the bytes and that sort of thing. So I just did it this way. So it would do each one of these. There's going to be an indexer here that will index. That would be the bonus. That entity LUT index property that we have back in global. I think that's what we're going to use here. So we're going to have the entity LUT index, and then whatever, I believe that will be it, or maybe it's another index. Whatever indexer we're going to use, we're going to step through this, and then each time the entity enters a new tile, will advance that indexer and then find out what is the next direction that the entity has to move in. So that's all this does, and it's per tile. So again, just the 4 entering paths, and then what we're going to do is going to put them in here, and then we're going to need with this to figure out the size of those arrays. So here we're going to get the size of the first one. We could hard code them in here, but if I make any changes, and I think I made quite a bit of changes in the beginning, I just left it that we'll use C's size of function to figure out how many elements are actually in the array. So, and that's what I do. So here I get, again, the 4 paths. So when I use a randomizer, it's going to pick one of these paths to go off of, and we're going to use it again, that pointer array. And here we're just defining how many elements are in it, so that when we know when we're at the end of that path to do something else, change the state. So, and the 3 states again that the bonus is going to use is the entering state, it's going to use the ghost house state, and it's going to use the leaving state. Those are the 3 states that the bonus is going to have. So, and we can look back on that here. So we have the entering. So we're just going to reuse these: entering, leaving, and then house. Those are the ones that are defined for the ghost, but we're just going to reuse them here for the bonus. So those ones will be applied. So moving on again. So I'm just going to put more of this information here. So again, this is the stage 2 ones, and I guess I'm just going to bring all of that information here. So that's the second stage, and this is going to be quite a lot of information here. So it's going to be 2, 3 has their own ones, 4 has their, and then 7 here. As you recall, that the unique stages is 1, 2, 3, 4, 5, and 6. Reuse 3 and 4 respectively. So that's all the information we're going to need. The 7th one is a special holiday one I put together, and as you can see, I made this probably as simple as possible. I didn't really put a lot of thought into the pathing, so it's very simple. And again, that only has 2 entrances, so you can see that the data kind of doubles itself out. I didn't really need to write it this way. I could have just used 1 and then doubled it up here in the array here. I would have saved some space. And I think I doubled up some other ones here, but for readability's sake, we're going to do it this way. And then the next set of data that we're going to have is our constants are the exit path. So once it goes around into that mid path here, so once it goes around the house and it gets back to its original tile, then we're going to get another randomized number, and we're going to see what path the bonus is going to take out. And this is all the paths defined here for the exiting of the stage. As you can see, it's quite a lot of data. And again, I could have skimmed down on it and done some different things to make it less bulky, but it's not that big of a deal for this game, considering that it's not a lot of data code-wise. Our next one is set bonus path, as I've done with the player entity or the player source code and the ghost source code. I have made a loading method or function. This is the same thing. This is setting up the bonus when we call it, and it's no different than those 2 other entities, other than what it gets done here. So there is the bonus path size. This is going to be our current path, and this size is the amount of elements that we got from this sizes array. So we're going to figure out, okay, is this size greater than 0? If it is, then we don't need to set the bonus path size. If the bonus path size is 0, then we would need to fill it with information. That's all it's doing here. So we're checking if it's already set. If it's not, if it is, then we return, sorry. And then we're going to reset our 2 other global variables, which is to be our path index. So that will be the indexer that goes through our path and updates the direction of the bonus as it's going along inside of the stage. And then here we're going to 0 out the bonus path size for whatever reason. I don't know why I do that, actually, because it should be 0 by this point, but whatever. We do it that way. And then here we're going to get a random number. Again, we're going to feed it bit 6, which I think is what was it was 64. And then if you take 255 divided by 64, that's a possibility of 4 different values that can come back from this random number generator. And then we're gonna, for giggles, I'm going to put in, as part of the get RNG, I'm just gonna put in the index of the bonus, which really doesn't have to happen here, but I just give it that for whatever reason. And then we're going to figure out that number. It'll be 0 to 3. And then whatever the bonus's state is at this point. So if it's entering, then we're going to do this portion of the code from here on down. If it's at that house state, then we're going to circle around the house. And then if it's at the leaving state, it's going to do this code down here. And we'll go over that. So if it's entering the stage here, we're going to check what stage map we are. So stage map means the current map layout that we have at this point. So we're going to check it. And so if it's 0, what we're going to do is going to set up our the tile index that the bonus is going to start on. So remember, we got that. This is where the bonus stage 1 starts at. So we're going to figure that out based on the path that we got randomized for. So we get that randomized starting position, and then based off that, we're going to get our randomized bonus path based off of that, and then the actual bonus path size. So we're going to set up those 3 variables here when we're entering, and that's going to be based off of whatever our random number is. So or I mean whatever stage map is. So whatever stage map is, and then this will be the random pathing that we get. And then here again, if it's this layout, we'll use bonus stage 2. And as you recall, that stage 2 and or the layout at least, and stage 4 layout use the same layout. So we're going to have a fall through here, and that'll be this chunk of code. So if it's a 2 or a 4, we're going to use our layout for the bonus stage 3. And then if it's 3 or 5, then we're going to use the 4th array that's going to get our entering path and our starting position. And then here, as you can see, if it's that last stage that we created, the holiday stage, then we're going to get it specifically from the stage 7 starts. So that's based off of all 4 layouts. And then if none of this is true, which should never happen, but if it does, we're just going to return. Here, we're going to call that entity function, which will set the position of our bonus. So what it'll take is that entity tile that we got here. So here, that tile index, and it's going to convert it into actual coordinates for us and set the entity to those coordinates. So the X and Y tile coordinates there. Although that doesn't really, we could have done it simpler here and made it that it isn't by index and we had pairs of X and Y, but since we use the tile index everywhere else, it just seemed like it was natural to do it here. Although it would probably have been better just to give hard-coded X and Y positions on the positioning where the bonus would be, but that's what we did here. So, and then here we're going to offset just a little bit because it's a snap position and we want to be in the center of a tile, not at the snap position of that tile. So we're going to add 4 to the vertical positioning of the bonus, so it's dead center inside a tile when it starts. So that's what we did there. If it was that it was the house state, we don't need to set the entity tile index of where it starts because it's already on the screen at this point. It already entered the screen. So now we're just going to go and set the bonus path to that circle path that goes around, and we're going to get the path size of that from the bonus circle path. And it's only 1 value there, and it's going to do its thing where it goes around. And then again, when it's at the end of its path, then it's going to go back in here and get another setup. So now in this case, we are leaving the stage. So very much like the entering one, we're going to still have that random number that's going to be generated. And we're going to use that random number here to get the path that we're going to use, again, the path size. And that's all we have to do here. And then at the very end of it, this is where we're going to set the direction, the beginning direction that the bonus will be going in. So it'll be the first element of our bonus path that we just got. And then the previous tile, we're going to make it the same as the current index because we don't need it to update the position just yet. So we make them both equal. And then later, as we use other code, when we check when these are different, like we have done with the ghost entity, then we're going to update the next direction and that the bonus is going to go. So again, that's all tile based. Set bonus, so this is when either I think when the stage starts up or when the bonus reaches the end or leaves the stage. We want to reset it so that it has a state and then all these other variables are reset. And here I put the bonus off screen so it can't be seen. I used 208. I don't know why I used 208. That's probably not a good idea, but whatever. It's at 208 at that point. I think, and I don't know if I brought this up before, but normally, from what I understand, and from what I read from the documentation, I'd be wrong here, But I think if you set an entity, if you set a sprite at 208, it will essentially turn off all the other sprites that are on the screen. I don't remember what the exact reasoning was for it or why they had that behavior. I'm sure there's some reason. But the thing is, since we're using Devkit SMS, it will save you from that behavior, because that would be, for most people that may be deving in this for the first time, they're not going to know that up front, that that's a behavior that the Sega Master System has. So at least if you use Devkit SMS in safe mode, it will handle that. You can compile Devkit SMS into an unsafe mode where it doesn't do certain checks and it doesn't do certain things for you that are the bells and whistles that it usually would do, just so you can save, a couple, I don't know how many cycles or scan lines you get out of that. I remember compiling the unsafe version of it, and it does give you some more performance out of it, but I wouldn't say, I don't know, it's up to you. Trade-off for me wasn't worth it, so I just used the safe mode. And the other things that what happens in safe mode that Devkit SMS does for you behind the scenes that you don't see is it also checks if your sprite count is over the maximum amount of sprites. So the maximum amount of sprites that you can have on the screen is 64 sprites altogether. So checks that overflow so it won't corrupt your game. Checks this 208. I even think, from what I understand, also the sprite positions are off by a pixels. So if you say to put a pixel at 0 on the screen, I think it's 1 pixel. It draws at 1 pixel more than what did. So if you say you draw at 0, it would actually draw at 1, I believe. So I think it corrects those things. There's a lot of small things that you don't see that Devkit SMS does for you. So, and one of the benefits of at least using this library. So, and I just want to kind of go over those small details there. So it's another thing there. You don't have to worry about those underlining issues that would maybe confuse somebody who just started developing for the Sega Master System. Because, and from what I understand, Nintendo has also the same behaviors with that 1 pixel offset too. From what I remember reading somewhere along the line, that Nintendo also has that same behavior where if you say you want to put the sprite on pixel 0, it would actually be 1 pixel more than whatever you say, and that's both on the X and Y positioning. So I'm sure there's a bunch of other caveats that I'm missing here and not thinking of, but I mean, it basically safeguards you from all that stuff. And if you turn that off or you compile it where it's unsafe, then you will have to manually deal with those issues on your own. So you're going to keep track of your sprite counts. You're going to keep track of, all right, our offset, unless you desire to have the offset by 1 pixel, and some other things there. So I just want to give some background there, and this kind of reminded me of that. So moving on. So again, this resets all those properties for the bonus. Okay, so I misspoke a little bit here. So this sets the bonus path. I'm sorry, this will do a load, but it's not the same as those other functions we had for the other entities. It's this one here. So this loads the actual data. I'm sorry. So I thought that first one, usually it's typically the first one, will be the loading data portion, but it looks like I had to define that first so I can call it here. And that's one of the things I talked about way back in the beginning of this tutorial, is that you need to define your function first before you use it. So set bonus path was defined up top, so now we can use it. If it was defined below here, the compiler will start complaining about it. So here we would give it the state, then we'd set the state for the bonus, and then we would do some normal setup. So we would set the base speed to 0, and then our fractional portion to half of a pixel speed here. So 120, I should be using 127. 128, I set it for whatever reason, and then we reset our entity timer as well, which I standardly do when it comes to this stuff. And then here we reset the bonus with all the other information. This is our setup, But then this is some other information that we were set not only here but outside of here when we go to create the bonus entity. And in here, we're going, if it's what the state that it's entering. So if it's an entering state, then we're going to set our bonus path to that point. If it's some other state, we're not going to bother with it. This is just when we first load it up. It's going to obviously want to be entering as the first behavior, or it's going to want to enter the stage as its first behavior. Update bonus tile. So this is just loading the tile graphics. So we have two slots. We have the first bonus and we have the second bonus that comes in. So this slot will either be a 0 or 1 coming in. And what we're going to do is we're going to check the current stage. If it's less than 7, the type will just be the number of the for the stage. So, and that's going to just basically set our level for the bonus at the bottom of the screen. So we know what type we're on at this point, and that coincides with the stage number as the stage gets incremented too. But once it's over 7, so 0 to 6, 7 of them. Once it's over 7, then we're going to get a random bonus. So remember way back in the global source code, we have a bonus array which has 32 bonus items randomized. Well, not kind of randomized in there. They're in sequential over and over again, repeating. So now we're going to get a random number that's from 0 to 31. So 32 different values that it could be. So we're going to get a random number. Here we're going to randomize it just a little bit because we call this one right after the other. So bonus 0 and bonus 1, we want to do a little bit more offsetting here. So all I would do is take the slot and I times it by looks like 32 or whatever. So that's just to get a little bit more out of the randomization, or at least offset it so it's not exactly, the chance of it being exactly as the same as the first bonus versus the second bonus will be lessened at that point. So here we're going to get our value from 0 to 31 so we can pick the bonus. And then we're going to add the cherry entity. This is because the type will have to be offset by 7 because remember our entities, if this entity cherry was 0, it would be fine, but we have to offset to what the actual entity type is. So we're just getting any type here. We're going to take whatever our value is. I'm going to add 7 to offset to get the correct type. And here, bonus types, slot 1, we're going to set what the first bonus coming in, whatever that type is, cherry, strawberry, banana, whatever, all 7, whatever those 7 are, we're going to set that here to the current slot. It will be either the first bonus or the second bonus, and we're going to fill that out. And then, let's see what else we got here. So we have the index. Okay, so then based off, I have the graphics in that sheet in a certain order. So again, we go back to that sheet. We took this sheet here, and this is all the bonus items, and I guess we can look better here. We look at the meta sprites and we look at the bonus. It's this sheet, and again, we have this sheet in order of how we have our types. So our types in order would start with cherry, then strawberry, then the apricot, orange, and so on and so forth till we get to banana. So what we do is, again, strategically placed, we're going to take our type and then we're going to minus that value that we have here so we can get back to 0, because we're going to use that for our data here. So it'll be whatever the type is. So in this case, it'll be either 0, 1, 2, 3, up to whatever the banana would be. And then we're going to times it by the full amount of data that one bonus can be. So what does that mean? So if we go back here and we look at this sheet, we have 1, 2, 3, 4 meta sprites that make up the cherry. We want to copy this entire block into VRAM. So if it's at the index is 0, you take 0, and then here we will count out how much data is here. So remember that these were 1, 2, 3, 4. So 4 times 32, because each block is 32 bytes in size. We said that was 128 for each block. So 128 and 128, 128, 128. That's 512 bytes altogether that we have to write to VRAM. So if it's a cherry and it's at 0, then I'll just copy this 512. However, if it's a strawberry will become 1 at that point. So 1 times 512 will start here at 512, and then we'll copy that 512. But if it's the orange or apricot, that will be 2. So 2 times 512 will start here to get our block of data, so on and so forth, till we get to the banana, which is the maximum. So that's what we're doing in this portion here. We're going to times it by 512. That's where our starting index into the byte data or the graphics data, where it's going to be. So we have our index of where it starts, our data starts, and then we're also going to get our destination in VRAM, where we're actually going to put it. So there's only 2 places that the data can be copied to. It's either at tile 220, or it can be copied to tile 236. And I guess let's see, what is a good way to look at that. So here, when we did the Metasprites, you can see our Metasprite starts at 220. So, and it's this many Metasprites, so it's 4 of them. So this is where the 512 bytes of data will lie, and this is how our Metasprites will be defined by tile. So as you can see, bonus 1 starts at 220, whereas bonus 2 starts at 236. So that will be where our destination is for the information. So here we're going to get the source within our bonus tiles, the actual graphical raw data that we have here in the assets that we have banked. So that's where we're going to start reading our data from, and then this destination is where the data is going to end up in VRAM for us. So we're going to use Devkit. We're going to use Devkit SMS functionality for that. So first, as I said before, we must, if we're going to use a bank that's been created with our assets, we must bank switch to that resource. So we're looking to get the data from the bonus tiles binary file. So we're going to switch over that bank so we can start reading that data in, or manipulating the data, whatever may happen. So we're going to switch our bank to that. And then here we're going to actually load the tiles. So here, again, we're going to do this pointer into our actual tile data, all the pixel data that we had there that we looked at. So here it's 3,584 bytes of data, and then we can verify that over here, 3,584 bytes of data that we have in this resource. And we're going to start at where we calculated our start positioning to be. So that's where we're going to start, and then this will be the destination portion, and this is by tile. So where it says source, our source is that's where we're going to point to get to start getting our data from. The tile from is the tile that we're going to put all this data to in VRAM, and then size is the total amount of bytes we're going to move over to the VRAM. So what we're going to read and then send over to VRAM. And as I said before, the total amount of data for the bonus graphics is 512 bytes. So that's what we're going to move over there. It's 512. And we're going to load it into wherever our destination is. And again, that will be for either slot 1 or slot 2. Here we check that. If slot 1 is the first bonus, then we're going to put it at 220. And then if it's the second bonus, we're going to start at tile ID 236. And that's how this whole thing works. So in essence, this is sort of like streaming, except we're not using the unsafe version of it. And we're only doing this when we load up the stage. We're not going to keep running. We're not going to keep writing 512 bytes over and over again. Otherwise, that would take way too much processing time for the MES system to handle, or the Z80 to handle. So here we just do it when the stage starts up. we're going to figure out our randoms when the stage starts up, and we're going to put all our graphics we're going to need for the bonus when the stage starts up. And that's all this does. Here we have the same kind of functionality as the other two entities, the players and the ghost entities, where we're going to update the sprites for the bonuses. So again, we're going to check we're going to set the visibility, so if they're on the screen or not, and whatever from the top or bottom, we want to know that. We're going to offset the X and Y exactly the same way we did the other stuff. Actually, this looks pretty much the same as the ghosts offset. So again, we're going to offset so that the origin's in the center of the graphic. Here, if the entity was eaten or consumed by the player, so we're going to check that. And then if the bonus is within the viewport, as in we can see it, we're going to set its sprite or meta sprite to the bonus point. So, and this is the bonus type index, so whatever that bonus type is, again, which was, if it's you know, strawberry or whatever, banana or whatever, we're going to go in here and get the points that we needed for that bonus points, and that'll be based off of either it's the first bonus coming in or a second bonus coming in. So we only draw this if it was in view. So this happens when you're playing team mode and the second player may have consumed the bonus, but it's off screen, so you can't see it. But if it's not chomped, and we're not pausing, because the bonus bounces as it's moving along. As it's moving along from one tile to the other, it's bouncing. So as long as it's not paused, and when it's paused, it's going to be mid-bounce at that point if it is going through this. So as long as it's not paused, we're going to use our entity LUT index. So, and we're going to use the index bonus because it'll be hard-coded here. Nothing else is using this code. So we're going to look at the bonuses wherever it is, and it's lookup table index pointer, and we're going to set that by checking if we're not over the size of the array. So remember that bounce array that we had in globals that had 18 elements. So we're going to see if, okay, we're going to ask the question, is it bigger than the maximum amount of elements in the bounce array? If not, if it is, we're going to reset it back to 0. If it's not, we're going to increment into the next one. And again, the bounce array, and we go back to it, so we go to definition. As you can see, the bounce array is just a bunch of single numbers. So as the entity is being moved, we're going to add this offset to it. So as you see, it's a -1. When we add a negative number, or we subtract from the Y position, it goes up. So here we're slowly going up here, and this one we go up 1 pixel. Here we go up 1 pixel, but then later we go 2, and then 3 and 4, and then it goes back down to 3, 2, 1, and then back to 0. So it's going to have this offset or effect on the Y coordinate where it offsets it and makes it look like the bonus is bouncing up and down based off these single offset numbers. So, and that's all we're doing. So we're going to set up where we are in that offset and that bounce as long as it's not paused. And then once we get or we set that LUT on what that value is, we're actually going to apply it when it's in view, and we're going to add it here. But when it's a marker, it won't have that offset. So, and that's what we're doing here. Although I think later in the game, didn't I add this regardless? I think I may have made it bounce regardless. Yeah. So here I'm adding it. Okay, so yeah, I do add the bounce to the marker, sorry. So, but in this one, when it's on screen, it will use the Y coordinate here by adding or to that offset, so it looks like it's bouncing on screen. But when it's a marker, we still want it to bounce, but we want it at a hard-coded value at that point. So if it's at the top or at the bottom, it's just going to use the raw value from the bounce. Instead of adding it, we're going to set it to what it actually is here based off of the LUT. So and you'll see this being used down here later. So we're going to use that for when it's out of view, out of view the top and out of view at the bottom. So this would be a hard number. So basically the index that we're currently at, which I don't know why I couldn't even use that, but I guess it was faster to set y to that. So it'll be that -1 or 2 or 3, depending whatever it is. And then we're going to apply it to the top view. So when it's at the top with these coordinates I have here, I'll take 4. So it's 4 off the top, and then based off this offset, it's going to bounce up at the top. It's going to bounce up and down with the marker, because again, I wanted to show that the bonus item is off the screen, but I also want to make it bounce so that the user, their eyes are gravitated towards it, so they know now that the bonus is there without even the sound being there. It'll show the top and it'll bounce, so it'll bounce, and the other markers, like the ghost markers, won't bounce. So it'll give it some kind of visual indicator that, you know, your bonus is at the top. And the same thing at the bottom, we're gonna have hard-coded value, 172 at the bottom, and then all it's do is has offset based off of this. That'll bounce up and down at the bottom. So that's all we're doing here, and then setting the correct sprite. So we're gonna set up whatever the marker is for this bonus type based off of the bonus type index. So whatever index it is, some 0 to 6 or whatever it is. So we're gonna get it that way for our sprite, and then we're gonna use Devkit SMS to add that sprite to the SAT. And then if it's on screen, as in the regular bonus sprite, then here we're going to use just the regular bonus sprite based off of the bonus type index. And there's no animation, there's no frames of animation for this. All the bonus graphics are they're just 1 frame each. So, and that's how we're going to do this. So we have bonus sprites, we have bonus down, bonus up markers, everything else. And here, if it's consumed, we're going to use the bonus points for it. So those 4 graphics total that we have set up, this is how they're all used here, and this is how we condition on them. So as the bonus is going around, we're going to check the collision every step of the way. So here we use our base check and collision. So this is checking against the players, whatever. See if we got anything. If we didn't get any sort of collision from the players, we're just going to bounce right out of it, returning back to the calling code to tell it that we didn't hit the players or we didn't collide with the players. However, the rest of the code here is when we do collide with the player. So here we're going to set the state of the bonus to chomp. That means it was consumed. We're going to add the score at that point. So whatever the bonus type index is, so whatever fruit it is, whatever entity is, we're going to add the score based on those bonus types. So if it's a banana, we're going to give it 5,000. Orange, or he used orange here, that's 500 points, whatever. So that's what we're going to do here. We're going to add our score using those HUD source code routines to update the in memory number, and then if it's visible later, it will be updated visually on the screen. So then once we do that, then we play a sound effect of the bonus getting consumed, and then we return that yes, we in fact collided with the player or players. This is something we use for the keeping track of where the bonus is within its pathing. So here we're going to check if there was a collision with the player. If there was, we're going to return so that the chomped state when on the next loop will process at that point. So, and then this won't be called from that state. But if it's moving currently through state, there's no pausing, whatever, we'll call this. Again, we'll check if it collided. If it did, then it'll bounce out. If not, then we'll do this code down here. So we're going to check if there was a difference in tiles. So if the previous tile and the current tile are not equal, then we know that the bonus moved into a new tile. And we're going to move that path indexer, bonus path indexer, by 1. And then we're going to make sure that these two tiles now equal one another, so we don't process again. So, and then what we're doing is going to play the sound effect of the bonus bouncing. So we'll play that sound effect. And then we're going to check if it reached the end of the path. So the entering path that went into, did it reach the end of it? If it didn't here, we're just going to keep setting the next dir up, or direction, for the bonus to continue following. But if we've reached the end, we're going to set whatever the next state is. So here we're handing it the next state after it finishes the path. So typically when the bonus enters, so it's in a state of entering at that point. But whenever we check this, the next state would be the ghost state. So that's what we would do here. So we would set the next state, whatever that state is. And then we reset our bonus path size and path index at that point. And then if the next state is none, that means we went through all the states and the exit state was the last one that we went through. So we're going to reset all our variables for the bonus. We're going to not draw it anymore, and then we're going to return. That's if it's at the very last state, which would be the handed state coming in here. If the next state would be to set it to none, that's what we would do here. If not, then we're going to set the bonus path. So we're at the end of the path. We need to get whatever the next state's path is. So when we first start off, it was entering. So, and then based off of whatever our next state here, it may be the next state is ghost, or the ghost house, and we would call it again here, and it would refresh our path around the ghost house. And then when that's done, again at the end of the bonus path index, we would look for the exiting path, and that's how we would set it here, and so on and so forth. So that's what it does here. Here, after everything's figured out, whatever it may be, some of these we're going to kick out early based on what they are. If we're turning off the bonus, or if there's a collision, we want a different state being processed at that point. As long as those don't happen, we will move the entity, or the bonus here. We're going to give it the index of the bonus, and then the direction that we're currently on based on what we set here. And we're going to then move it the amount that the speed of the bonus entity is, which is about a half a pixel. And then here we're going to update our current tile at that point. So that's what's going to happen here. And this is going to be run in a loop as long as the state allows it. So that's all that is. And that's really the lion's share of the processing we're going to do for the bonus. And the last, I believe this is the last one. Is this the last one? No, it is not. Sorry, not the last one. This is the last one. So as we had with the ghosts and the players, we have this update state method that we use for keeping track of the state. So here, if it's paused, we're going to return. We're not going to process any of the states that are here. And then if it's not paused, then we're going to check whatever the state is of the bonus. If the bonus was chomped, then we're going to have this timer that waits 120 frames. And the reason why we do that is to show the points on the screen for a while. So after it gets the bonus gets chomped, we change it over to the chomp state, and then we wait 120 frames for it to show. So, and how that coincides. So if we're in entity state chomped, if you go back to the sprite here on the, when it goes through it, it always loops to show the graphic here. So when it's in the entity state chomped in here, that's when we're gonna show those bonus points, whatever the points are. We're gonna show those sprites on the screen, because at this point the state of the bonus is that it's been chomped. So we're just going to show that graphic for 120 frames. Just NTSC, I think, is about 2 seconds. And then once it reaches that threshold, we're going to reset the bonus, and this time we're going to set it to none so that it doesn't draw. Here's when the bonus enters for the first time. Here we're going to keep calling this bonus follow path to update its positioning in the path array. And then here we're saying, okay, if it's entering, then the next one we're going to want, after it gets to the end of the path, we're going to want it to go into the end state of going around that ghost house. So we're going to set it to that when this path is done. And then here, when it's in that end state of house, we're going to do the same call, but this time we're going to say, all right, our next state would be actually leaving the stage. And then when we're actually in the leaving state, we're going to call the same exact thing, except this time when it's at the end of the leaving path, we're going to set it to none at that point. So now we're finished. The bonus will be reset for the next time we use it, which will either be one more time or it won't be at all, because again, it only gets called twice. So pellet count 70 and pellet count 170, that's when we change the state and bring the bonus in. And then finally at the end, here's our typical update function that we would normally call. Again, like I said, we have the loading function, and then we have the updating function, and this is what that is. This would be called from the engine, the game engine. If the entity state is none, then there's no reason to even look at any of this other crap down here. So we're just going to look. If it's in the state of none, then we're not even bother processing this. But if it is, then we're going to update the state, and we're going to update the graphics for the entity. As you can see, there's one less update function in this. Normally, like we had with the ghost and the players, we also have an update frames method, but since there's no animation at all when it comes to the bonus item, there's no reason to even have that method. So it's only one frame for any of the states that it's in, and that's it. So, and that's what we do here, and that's everything. So thanks for viewing, and the next one should be where we actually put all this garbage together, and I'll slowly go through that process. I'll be on the stage, source code, showing how we load the data, how all this comes together, how we'll piecemeal each one of these to show what the performance is based off of how many entities are being displayed on the screen, and we'll go over that in Emulicious and actually see the fruits of our labor come together. So until next time.